What if one person could decode the entire universe? What if a single mind, through silence, solitude, and stubborn obsession, could explain why planets move, apples fall, and rainbows form? That person was Isaac Newton, the man who turned chaos into calculation and left behind laws that still hold the cosmos together. This is not just the story of a scientist, it's the origin of the modern world. Isaac Newton was born in 1642 in Woolsthorpe, England, just days after the death of Galileo. He came into the world prematurely, so small they feared he wouldn't survive. His father had already died, and when Isaac was 3, his mother left him behind to remarry. She handed him over to her own mother, Marjorie Ayscough, his strict and distant grandmother. Isaac never forgot the abandonment. Later in life, he wrote bitterly of the rage he felt. He grew up isolated, deeply introverted, but endlessly curious. By the time he was a teen, Newton was already constructing machines from scratch. Windmills, sundials, even tiny cannons. He wasn't just clever, he was obsessed. At Cambridge University, he devoured the works of Descartes, Kepler, and Galileo. But just as his education began to blossom, catastrophe struck. The Great Plague of 1665 swept through England. Cambridge shut down. Newton returned to Woolsthorpe. He was 22 years old. And what followed would be one of the most extraordinary bursts of genius in history. Newton began asking, why do things move the way they do? After months of thought and experimentation, he laid down 3 simple but revolutionary rules. Law 1, inertia. An object at rest stays at rest. An object in motion stays in motion unless something interferes. It's why a rolling ball eventually stops, or a spaceship in a vacuum never does. Law 2, force equals mass times acceleration. This one explains how we drive cars, launch rockets, or lift weights. The bigger the force, the more acceleration, but heavier objects resist change more. Law 3, action equals reaction. Every action has an equal and opposite reaction. Push against a wall, it pushes back. Fire a cannon, the cannon recoils. These 3 laws became the foundation of physics. With them, we could predict the motion of everything, from apples to asteroids. Then came a falling apple. No, it didn't hit him on the head, but it sparked a world-changing idea. What if the same force pulling the apple down also keeps the moon in orbit? Newton proposed that every object in the universe attracts every other object, with a force proportional to their masses and inversely proportional to the square of their distance. This was universal gravitation. With this one law, Newton united the heavens and the earth. For the first time in history, a single equation could describe the motion of planets, moons, and falling bodies. Gravity wasn't just a force, it was a key to the cosmos. At the time, many believed white light was pure, and that color was something added by glass or surfaces. Newton proved the opposite. By passing sunlight through a prism, Newton showed that white light is made of all colors. When he recombined them using a second prism, the white light returned. He discovered the spectrum and shattered centuries of misunderstanding. To test his theories, Newton needed better tools. So he built the first functional reflecting telescope, using mirrors instead of lenses. This solved problems of distortion and color fringes in earlier designs, and it made the universe sharper than ever before. Today, nearly every large telescope, including the Hubble Space Telescope, uses his design. To fully describe motion, light, and gravity, Newton needed a new kind of mathematics. So he invented one, calculus. Calculus allows us to measure things that are always changing, like speed, area under a curve, or the orbits of planets. Though he wasn't the only one working on it, Leibniz also made major contributions. Newton's version powered the mechanics of the physical world. Without calculus, modern science, engineering, and space travel would be impossible. Though celebrated, Newton remained solitary. He held grudges, avoided praise, and hated criticism. He feuded with rival scientists like Robert Hooke and Gottfried Leibniz. When Hooke died, Newton allegedly ensured that no portrait of him remained. In his later years, Newton became warden of the Royal Mint, where he tracked down and prosecuted counterfeiters personally, but he was still drawn to the mystical. Newton studied alchemy, the Bible, and ancient prophecies. He believed God had encoded the universe in mathematics, and it was his job to translate it. In 1727, at the age of 84, Isaac Newton died. He was buried in Westminster Abbey, an honor reserved for kings and heroes. Do you like stories like this? Then hit the like and subscribe buttons and join us on the Science Hall of Fame as we explore the lives of the greatest minds in history. One idea at a time, one legacy at a time.